Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to day 41 of NL Math Man's Math Help Streams. We are, for the background today, we are back in NL. We're back at the cabin, although we've taken a bit of a fourth dimensional trip, right? Yesterday I was talking about the number of dimensions in our reality, and it turns out we do indeed have four, right? But one of them is time. However, that dimension tends to move you know, mostly forward at the rate of 1 second per second. But occasionally we can sort of take a trip, back in time a little bit. I mean, not literally, but we can through the power of imagination, memory, sometimes metaphor and simile, but through imagination, right? We can go back to a previous time. What I have here in the picture is a previous time at the cabin that I had alluded to before. What we see there in sort of the bottom middle, sort of above the word ladder, is that fire pit that I had mentioned that I built out at the cabin, right? I found this picture while digging through some of my old files. This was the fire pit is a bit old here now, like not old, but like the fire pit was probably put in the previous year in this picture. I know that because all the land around it has been reclaimed by the grass. So if you can see, the plants have grown up all around it there. Because of course, after I installed it, you remember I talked about how I took the dirt that we removed to put the skirting around the cabin. All that dirt was brought down by the water's edge and made into this fire pit, right? So we've seen the grass sort of grow back up down there. And next to it, down there below where the word factors is, you can see a path, a sort of a flagstone path that I had just installed. Now that is brand new in this picture, I believe. I think that's because you can still see the sort of the dirt around it there, so the grass hasn't sort of grown back up around it. And the grass and weeds and stuff at the cabin grow very thick indeed, as you can imagine, right in a place that's only inhabited like a few months of the year, right? So yeah, those stones they stayed there. I mean, until until the excavator came through last year. Now they're totally out of there. I'm not going to be able to reclaim those stones, but they weren't like bought flagstones or anything. They were just uh, pieces of shale that I sort of scavenged, I guess. Not really scavenged, scrounged, found. I mean, found's a good verb. Found's a verb, right? But it's not a vivid verb, right? We talk about those in the English program. You got to use vivid verbs. See, scrounged. That's a vivid verb, right? Scavenged. Um, I don't know. Repurposed. That's not really appropriate in this case. But anyway, I scrounged those pieces of shale from a pit near the cabin, right? And that's what I made that path out of. So in this picture here, you can see it nice and fresh and pristine, right? Um, yeah, leading to the fire pit. That alas is no more, but the vista out there overall will be improved, I do think, and I'm looking forward to getting out there this summer. After classes end in CBS, I'll probably be heading out there. Now, I have had some questions recently about when indeed classes are ending in CBS, and like I've mentioned before, they are ending June 26th, the last day of June, which is, I believe, the day that high school would have ended if high school was still really going on. And that date is set by AESL, the funding agent. That one is not set by Academy Canada, or for that matter, any of the other satellite providers, because the satellites, just a little peek behind the curtain, right? The satellites, even though some of them are run by different schools, they're all sort of funded under the same banner of AESL, right? So those ones will all have the same end date roughly, which will be the end of June. Now, for my students, I believe you'll be able to keep doing your studies via distance from Kenmount Road, but I'm not 100% sure what the exact setup is going to be for that. I imagine that I'll just send my colleagues at Kenmount. I'll send them the current marks that you have for any courses that are going, and then they'll just pick that up and run with it. Right? I believe there's several students looking to transfer. Rest assured, we are aware of that. Right? It's not just being put off. Um, and when we're actually over into June proper, somebody, probably me, will send around an email to all the students asking if anyone wants to transfer, right? But before that point, we will iron out some more of the details. Yes, good afternoon, Esther. It's good to see you there. Um, yeah, I believe I sent you off some notes there about that last activity you gave me. I don't think there was anything specific that I really needed to get to on that. Um, but if there is anything you want me to do, just let me know, and I will be able to stick those on the stream today for sure. Maybe get to them first, even seeing you're here watching. But yes, we are on top of the whole transfers scenario. So don't worry about that. It's not being forgotten or anything like that. You will all have the opportunity. Well, if indeed transfers are going ahead, which I imagine they are, you will all have the opportunity to participate. Seeing, CBS is in a unique sort of position, right? That we're close to one of the larger campuses. CBS and I guess Deer Lake, right, could probably go into Corner Brook if they wanted. Although with it being off site now, I guess that kind of flips everything on its head a bit. Either way, uh, myself and the other staff in CBS, which is obviously just the other teacher, we will be done as of June 26th. But anyway, um, yeah, for today then, I'm going to go into unit conversions and metric ladder. We're going to talk a bit about those. Um, that is a topic that I have covered before. Not having any problems? All right, great, excellent. I'm glad to hear it. Yeah. You seem to be doing pretty well with this current course. Yeah, this one is like real life stuff, and then a bit of simpler sort of geometric properties. So this one's a pretty decent course. Seems like you're getting through that one pretty quick, right? So let me know if you've got any questions about that. But yeah, I'll be ready to give you the final in that course tomorrow if you get the review sheet in. If not, I mean no pressure, right? Just I'm saying the option is there if you want it. Anyway, I am going to go over unit conversions and metric ladder today in a bit more detail than before. I'm going to sort of talk through, what a conversion factor is, what it stands for, and then instead of going into the cross multiply method, which I do like, but instead of that, I'm going to focus entirely on the unit canceling method and sort of explain what it works, explain why it works, what it works. Then inductive and deductive reasoning, Betty Ann, I'm just going to do a bit on that topic because I know you're approaching the exam in that course. I don't think that topic was particularly difficult for you. I didn't pick it because I think you need review on it or anything. I just picked it because that was an earlier topic in the course, right? That you're going to have to return to review for the test. So I thought I'd go over a bit of that. Hoping to get it done? Yeah, great. Okay, so I am going to, let's see, we're going to switch on over here to my document display. How about instead of the snow pond, instead of the snow, let's go back to the green. There we go. That matches my intro screen for the day. How's that? Yeah. And right, and with the lighter sweater, maybe the snow is a bit too much, right? We got to get some nice primary colors in there. So to start off, I'm going to do a unit conversion recap. Now, this is useful for people that are in lots and lots of the different courses that I'm doing, right? Over on the side here, you see the conversion chart, right? This is one of the conversion charts that we use in the course, so this is where I'm going to be drawing the conversion factors from. These might not be 100% precise. Like if you were to Google it or something, you might get a slightly different one, but these are these are mostly like the rule of thumb or the more common ones that we're going to use, right? So, do I need to stay online as I want to get the review sheet? Oh no, of course you don't need to. You never need to stay online or watch the stream or anything like that. No, and yeah, I mean we've been doing this for a while, seeing this is day 41, but yeah, you know that the streams are not mandatory, right? I just do these to amuse myself. I do these for people to, if they want to come on and ask questions and feel more like we're back in class. It's just making sure that people have all the opportunities that they can in order to succeed at this distance program, right? But yeah, you don't need to, definitely don't need to hang out if you've got other stuff to do. So conversion factors tell us how many of one unit correspond to how many of another unit, right? So for example, say we had 1 kg equals 2.2 lb. Tells us that 1 kilogram corresponds to 2.2 pounds, right? So this is just the conversion factor that we are going to use for this, right? So 1 kilogram equals 2.2 pounds tells us that 1 kilogram corresponds to 2.2 pounds. And I guess I'm kind of saying the same thing over, right? Let me break out a different color here. So we can think of our factors as a number of one unit per a different number of another unit. Well, what does that mean? Well, let's pick another one of our examples over here on the side, right? So if I do 1 liter equals 0.2642 gallons, tells there's 1 liter per every 0.2642 gallons. Okay? So 1 liter equals 0.2642 gallons. Tells us there's 1 liter per every 0.2642 gallons. Now, phrasing it like that in this sort of language might not make a ton of sense to you right away, right? But this is sort of the way that I would like you to think about it. Sort of, there's 1 liter per every 0.2642 gallons, right? Because that tells us then how we can write it in math, right? So I can say now, okay. So in math symbols, per means divide, right? So we know, like we saw in some of the refresher courses at the beginning, where I talked a lot about, how we can write um, sentences out into math symbols. That's really important, and it's important to know, what the symbols correspond to in terms of words, basically, right? So per means divide. So we can write the conversion as 1 liter per 0.2426 gallons, or 1 kilogram per 2.2 pounds, etc. We can also flip these as long as we flip the units as well. So this is an important thing to know for what I'm about to show you for how to do the math, right? So we can say, just like we said these two over here, we can equally say 0.2426 gallons per 1 liter. Or we can say 2.2 pounds per 1 kilogram, right? So we can write them this way with liters on top and gallons on bottom, kilograms on top, pounds on bottom, or we can flip them. So what I'm saying is for any of the conversion factors that we find over here, oh, my cursor's not there, any of the ones that we find over here, we can write these as a fraction with kilograms on top, grams on bottom, or grams on top, kilograms on bottom. Either one is fine, and as long as we keep our units written there, then we're good to go, right? So to use the unit canceling method, make sure to write your units with your conversion factors. So what do I mean by that? Right? Well, you always, this liter and this gallons, this kilogram and this pounds, ones like there, those are not optional. Those always need to be there, right? Like say we were to do, where's kilometers to miles? Do we not, oh, this one, this conversion chart doesn't have kilometers and miles, does it? Oh, that's annoying. Okay, hold on a second. Hold on a second. Let me go and there's a few different charts that we've got. So let me see if I've got one here that has all of, I thought this one had all of them, but apparently it doesn't. Okay, there's our miles. Yeah, okay. Um, 1 mile equals 1.6 kilometers is the one that we're going to use, right? So I had to bring up a different sheet to see that one. Let's go over here. Let's go over here and go back to the cabin in the background. There we go. I like that one. And zoom on in. So say we have these conversion factors up here, right? Yeah, these are good ones. Okay. So we can say that there's 1 mile per 1.6 kilometers. And we read that, right? Like I said, 1 mile per every 1.6 kilometers. Or we could say 1.6 kilometers per 1 mile, right? Which is 1.6 kilometers per every mile. Right? So either of those are okay to use. Sometimes we'll need one, sometimes we'll need the other one, right? And now Renetta, I believe, hopefully, maybe you're watching this now, maybe you're watching this afterwards. You don't necessarily need to watch live, of course, but we've been over that. You guys know the regulations for these. Um, yeah, I will send you all this afterwards, but it's important to know, say, 1 mile per every 1.6 kilometers or 1.6 kilometers per every mile. Either of those factors are okay to use, right? But the important part is knowing that we write out the ones with an equal, like are above me here. We're going to write those out like what we've got over here, right? So say again, we've got 1 inch per 2.54 centimeters, or we can say 2.54 centimeters per 1 inch, right? Now why? Why is it important? Why is it important to know that we can flip these like this? Well, it's because of unit canceling method, right? And unit canceling method is, to my mind, sort of the easiest way to do any of these unit conversions, right? So let me bring this up. So unit canceling method. Okay, so by writing out units when converting, we can easily see how we should use our conversion factors, right? So what's important to know is that I'm gonna change that. So units follow the same algebra rules as variables. So units follow the same algebra rules as variables. They can be canceled, they can be squared, and so on. So the unit canceling method oh, I spelled it with two L's. Oh well. So unit canceling method is when we arrange our conversion factor to cancel out our current unit and leave us with a different unit. Okay? So, what does that mean? Is the teacher ever going to get into an example? Well, yes. So, say we wanted to convert 14 miles to kilometers. Right? So we know our conversion factor is that 1 mile equals 1.6 kilometers, or in other words, there's 1 mile per every 1.6 kilometers. Okay, first we write the value we want to convert, 14 miles. So then, Okay, so this is not supposed to be crossed out. This is supposed to be underlined. I just sort of scuffed that one a little. Then we rearrange our conversion factor so that our starting unit, miles in this case, is on the bottom of the fraction, right? So we have 1 mile or 1.6 km per 1 mile, right? So the red bit up here was me rearranging it so it's on the bottom. Right. So now we're left with an answer in km, right? Well, I know that 0.6 times 14, 6 times 14 is 84, right? So 6 times, so that should be 14 plus 8.4, which would be 22.4. 22.4 is correct. Hey, way to go, me. 22.4 km. Okay? So we multiply. So just to go down through this all from the top again, this is the unit canceling method. We have to always write out our units when we're converting like we're doing here. So this is an important bullet point up here. Units follow the same algebra rules as variables. So just like x's or y's are kind of just like constants as well, but I didn't include constants because, of course, constants, we can add constants with other constants. We can't add units with other units. When we're doing anything about like moving units around, they do function more like variables than they do like constants, right? So then unit canceling method is when we arrange our conversion factor to cancel out our current unit and leave us with a different unit, right? So you see down here, miles are on top, miles are on bottom, right? So if this were to say an x on top and an x on bottom, we know that those would cancel each other. The same thing happens with the miles here, right? And one of the useful thing about doing unit canceling method is that we know now, once we've done this, we know that our answer is right. We know that our answer is in kilometers because it tells us, because we're using this method, we know that we have to arrange our conversion factor like so, with kilometers on top and miles on bottom. Miles have to be on bottom because it's important that the initial unit that we're trying to convert out of, that's the one that's on bottom when we multiply by our conversion factor, right? So let me just, this is the initial value right here, right? This bit, and this bit here is the conversion factor. Right? So we're just going to multiply by them, and we're going to rearrange them before we multiply so that our units are going to cancel. All right, so now I'm going to do some examples. Okay, so Renetta, you earlier were doing the review sheet, I believe, for Unit 3. So I'm going to pop over to that one, and I'm going to do a few examples of this. Then I'm going to go rattle down through some ones on another sheet that I have made, which I will send you as well. So the other sheet that I do, I'll send you a copy of that. All right. So we notice here now on the review sheet that you were doing today, Renetta, that the numbers that we're converting, let me zoom out a touch so we can see it a little bit better. There we go. For the following conversions. So we notice that those ones are squared, right? Now, these questions are sort of not only two-part questions, but there is one other little tricky bit about these, and that you need to notice that there's a 2 in the corner of the units, right? You see over here, you see this inch squared that the hand is on top of? That's really, really, really important. Right? That's important. That's important. That's important. That one, and that one. They're all super duper crazy important. Why? Because it's a totally different unit, right? An inch squared is not a measure of length. It's a measure of area. It's a measure of space something takes up. It's an amount of space that measures 1 inch one way and 1 inch another way, right? So as a little bit of an aside, I do want to do this again before I get started and just draw this out over here. This shows why 1 foot squared is not 12 inches squared, right? So say we had a space like so, right? And say this amount of area was 1 foot that way and 1 foot that way. The area here is going to be length times width, or the area is going to be 1 times 1. So the area is going to be 1 foot squared, like that, right? But now, say instead we converted this to inches, and it was the exact same shape, which is the exact same size, but instead of talking about it in terms of feet and feet squared, we're going to talk about it in terms of inches and inches squared. Right? So remember, it's the exact same shape, the exact same size, right? But now we're measuring in inches instead. It's going to be 12 inches there, and it's going to be 12 inches there. The area is still going to be length times width, but now it's going to be 12 times 12, so the area is going to be 144 inches squared, right? So you can just memorize the different conversion factors for area, or you can read them off your sheet, or you can remember that whatever the conversion factor for linear is, it's going to be squared, right? Because this is 12 inches, this is 12 inches, so the full space here is actually 144 square inches. But over here, it's just 1 square foot. But that I'm going to bubble, because that is a bit of an aside. You are given those, so you don't necessarily need to know the reasoning behind it. But by now you might know my sort of theory underpinning math teaching is that it is very important to know the reasoning behind it, because that'll build resilience and it'll enable you to tackle problems that are a bit different than what you might see exactly. Some teachers will talk about rote memorization, and I even see some teachers call it like rote mastery, which makes no sense. It's a total oxymoron. It's a contradiction in terms. There is no such thing as rote mastery in mathematics. You have to understand why you're doing something in order to hope to master it. You can memorize how to do something via rote, via just like seeing the pieces and knowing how to multiply in that individual case or something like that. But without knowing the reasoning behind something, you can never hope to achieve mastery in any math subject or any math topic. And anyway, I am going to go through now and show a few of these ones. All right, so this is question 8 on the review sheet, 8A. All right, so we've got 504 inches squared equals some number of feet squared. Well, we know our conversion factor, because it's the one over here, right? We know our conversion factor is 1 foot squared equals 144 inches squared, right? But what we're starting off with, okay, so to follow the unit canceling method, first thing I'm going to do is write down the number that I'm starting with. And I'm starting with 504 inches squared, right? So I've got inches on top. Remember, just like what we looked at on the previous page, inches are the unit we're starting with. So whatever unit we're starting with, that one's going to need to be on bottom of our conversion factor, right? So our conversion factor here now is going to be 1 foot squared per 144 inches squared. And now we're going to go ahead and multiply, right? Once we multiply this fraction by this one, what do we get? Well, this now, again, is using a skill that you saw previously, which is just fraction multiplication, right? And of course, when we multiply fractions, it's top times top and bottom times bottom. And we know that any whole number, even though it doesn't have a denominator listed, any whole number is over 1. So we can call this, right? Our inches are going to cancel with inches, and we can call this 504 divided by 144 feet squared, which if we go ahead and just figure that one out on yield calculator, 504 divided by 144 equals 3.5. Now, I know what you might be thinking looking at this. Why in the world do I need to learn this stupid method if all I had to do was know to divide from the start? Well, that's fine. That's fine if you know how to divide from the start like that. But the problem is, what about the times when it's a conversion factor that you've never seen before, right? Uh, the usefulness of unit canceling method and a lot of the methods that I show is because of the resilience that they have. Whenever you apply this unit canceling method, it's going to work. No matter if it's the first time you've seen this conversion or it's the 1,000th time you've seen this conversion. You know what I mean? Whether you're a carpenter or a surveyor who converts between square inches and square feet, 100 times a day, or you're a student doing math 1102A unit 3 in Academy Canada CBS, and you've never seen this before and would hope to never see it again, no matter what situation you're in, the unit canceling method is going to work totally fine, right? But remembering, hey, in this case, I divide by 144. Oh, in this case, I actually multiply by 0.9. Well, it's going to be a lot more difficult in the end to try to remember each individual case. Now I'm going to slide over. Actually, no, hold on a second. Those ones are metric. I'm going to get to the metric conversions there now in a bit. But yeah, I'll put a pin in the metric ones for now because I do want to show the metric stairs as well today. But say for question C here, we've got, well, we know feet squared to yard squared. Well, I know that 1 yard squared is going to equal 9 feet squared. And this is also another one that you're going to see on your conversion sheet has this as well, and it's for the same sort of reason over here, right? We know that in linear measurements, a yard is 3 feet, but once we go into squared measurements, it's going to be 3 feet one way, 3 feet the other way, which makes 9 square feet in total, right? But this is now our conversion factor that we have. So what value are we starting with? Well, we're starting with 32.4 feet squared, right? And now we know that since feet squared are on top here, because feet squared are the one we're starting with, feet need to be the one that's on bottom when we put our conversion factor in. So we're going to have our 9 feet squared on the bottom, our 1 yard squared on top. We're going to end up with 32.4 over 9 yards squared, right? Because the feet are going to cancel with feet, or feet squared rather, because I want to be as pedantic as possible. So we're just going to do 32.4 divided by 9 and get 3.6. 3.6 square yards for that one. Right? And then just to go ahead and show the other one that I've got brought up on screen there right now, I'll do E. Right? So E is going to be, let's say, 6.7 feet squared. So what am I going to multiply this one by? Well, it's going to be the same conversion factor as the one up here, right? Because it's feet and inches again, right? So now I need to do this one, but with feet on bottom, right? Because we've got 6, so make sure the decimal is clear there, 6.7. So now when we do our conversion factor, feet need to be down below because feet are what we're starting with. So it's going to be 1 foot squared 144 inches squared. We take these guys and multiply. The feet cancel with feet, and we're left with 6.7 times 144 this time. 6.7 times 144, which is going to give us 964.8. 964.8 square inches. Okay, so that's a few from the review sheet. I'm also going to take the opportunity now to pop over and do a few other ones off of this other sheet that I've made. Then I'm going to talk a little bit about the metric conversion steps as well. Right, so let me just go over to here we go. Now this is from Math Aids, which is, again, right, something that I've used quite a few times. Let me switch over to the document display here so it's a touch bigger. You can see it a little bit better. Right, but I just went on and generated this sheet, which they call it English and metric. I don't know, maybe in the States they call it the English system. I've always referred to it as the imperial system, which I find it's a much better noun for it, right? The imperial system. It sounds very Star Wars, right? Yeah. Like the imperial system, I find your lack of pounds disturbing. I don't know. That wasn't great. I could have had a better joke there if I had, thought of what Darth Vader would say about converting units. But whatever, you know. We'll deal. Um, just to keep the name the same, Renetta, because once you see this one, you will be sort of referring back to it. This is going to be converting English and metric worksheet. We're going to be converting back and forth between the two, right? So off the top there we have feet and meters, right? So we're going to need to know our conversion between feet and meters. So if I go over here, let's see, we've got. Oh, did we not? We weren't given feet and meters on this one. Were we given feet and meters on the other one? We were given meters and inches. Hmm. That's a bit annoying. It's a little bit annoying that we weren't given that one, right? On our sheet. Whenever you're doing this on a test or something like that, you will be given these ones. So for purposes of keeping this more straightforward, I'm going to use this 1 meter equals 39.37 inches. I'm going to use that one as my conversion factor. And then I'm going to convert from feet to inches over on the sheet, right? So we bounce back over here. We've got, oh, we started with meters anyway. Okay, so I'm going to convert to inches and not to feet. We'll just deal with that, right? But so we're starting off now with 21.5 meters. Now we know when we bring our conversion factor over, now I need to make sure to have meters on the bottom, right? Because if I have meters on the bottom, then it's all going to cancel out once I multiply. So I've got my 1 meter on bottom and my 39.37 inches on top, right? Because this is the conversion factor that I'm using. It's the one that I was provided on my formula sheet. So I'm going to go ahead now. Meters are going to cancel with meters, and we're going to be left with 21.5 times 39.37, and we're going to get about 846, because 846.5 inches. Right? If I was to take that and divide by 12, we would get 70.5. So 70.5 should be about the answer that we've got on the bottom here. 70.54, there it is, right? There, we got it. Okay? And one of the nice things about these Math Aids pages, like I've mentioned, is that they come with answer keys as well, right? So if you are generating some of these in order to do some work on your own, or if you're working on the one that I'm going to send you after this is over, yeah, you're able to check down below to make sure that you're doing it correctly. I'm going to keep going through and do a few more of this one. So now we've got pounds and kilograms, right? So 2.2 is a normal one that we use for that, but let's flip over to our conversion sheet. Yes, so we are using 1 kilogram equals 2.2 pounds. So we get our 1 kg equals 2.2 lb, right? Pop back over to our the worksheet over here. Now, we're starting off with 18 kilograms, right? And because we're using unit canceling method, like I've talked about, we now know that kilograms are going to need to be on the bottom. So we're going to have our 2.2 pounds on top per every 1 kilogram. They're on bottom. Once we multiply now, kilograms and kilograms are going to cancel, like so. And we're going to be left with 18 times 2.2, which is 36 plus 3.6, which should be 39.6. There we go. Look at that. 39.6 pounds. Right? Yeah, let's carry on and do a few more of these guys. Miles per hour to kilometers per hour. That's a good one. That's a good one because you're not going to see a conversion factor from miles per hour to kilometers per hour. And why not? Well, because they're both per hour, right? So since the hour part is the same, converting miles per hour to kilometers per hour is just the same as converting miles to kilometers. So that's a tricky little one that you might see on a test. They might throw that curveball at you and give you a speed instead of a distance, right? But we know that the miles to kilometers is actually the one that we're going to have to use. So not on this one, it's on this one over here. Yeah, here we go. So sometimes you'll see this for your conversion factor. More often than not, though, you will see this. This is the most common one that we use. So 1 mile equals 1.6 km. Sometimes you'll see it written as like 5 to 8. But I'm not a super big fan of the 5 to 8, but you can use it. You can use 5 to 8 if you want. I like having one of my values to be 1 in my conversion factor. It tends to make the math easier, I find. But anyway, I'm digressing a little bit now. But it's just, differences in how math is taught in different places, right? Like when I was in the UK, miles to kilometers is a very important conversion in the UK because, like I've said, their posted speed limits are in miles for whatever reason. But like you go over to the continent, into Europe, and all of a sudden it's in kilometers, right? So it's sort of the same sort of deal that we've got here in Canada with going to the States. Canadians need to be aware of the difference between kilometers and miles, right? It's super important for Canadians to be aware because if you no, actually, wait a minute. Scratch that. Reverse it. It's super important for Americans to be aware because they're used to driving like 65 or 60 or whatever miles, and they come over to Canada and they see 110 on the 401 or whatever, and it's like 110 miles per hour. Boy, just put that pedal down. I'm not sure my car can get to that, you know. But if you're a Canadian going to the States and it's like, well, I'm used to driving 100, now I got to drive 60. What is this nonsense? 60? Come on. Anyway, 1 mile equals 1.6 kilometers. So we have 6 miles here, and we're going to have to convert that one into kilometers, right? So again, because miles are what we're starting with, we need to have miles on the bottom. So 1 mi is going to be on bottom, and 1.6 km is going to be on top. Now, the miles are going to cancel with miles. We're going to have 6 times 1.6, which should be 9.6. Not even going to do that one on the calculator. I know that one's 9.6. 6 times 6 is 36. So 6 plus 3.6 is 9.6. It's not that hard, right? Said mental math is all about shortcuts. It's not about actually being good at math. It's about being good at being lazy. Find the easiest way to figure something out. Okay, yards and meters. Let's do that one next. So question 4. So yards to meters. Where's our conversion for that one? Let's go back over. Right? Nope, I keep switching to the wrong one. Here we go. 1 yard is 0.9 meters. So we're going to write that one out. 1 yard equals 0.9 meters. Right? No way around this. You've got to flip back and get your specific conversion factor every single time. That's just what you got to do. Right? So we're still on question 4 here, right? So I'm starting off with a number of meters. Since I'm starting with a number of meters, my value for meters are what has to be on bottom over here, right? So 1 yard per 0.9 meters. Now the meters are going to cancel with meters, but what I'm going to be left with is 4.5 divided by 0.9 for yards. So I'm going to go ahead and work that out. 4.5 divided by 0.9 is actually going to be 4.5 times, yeah, there we go, 5. So 4.5 meters, pretty much exactly 5 yards. Right? Oh, no, no. Okay, we're slipping. We're slipping a little bit there. All right. So that should be a decent look at the unit canceling method. I am, like I mentioned before, I am going to go over a little bit about the metric conversion steps as well, and then I'm going to bounce back over and do the last questions on that review sheet. And then Renetta, I think that should be a reasonably exhaustive look at what we're doing here, right? But the metric conversion steps, metric conversion is not quite like what we see on there, right? The metric ones are always factors of 10, which is one of the things that makes them a bit easier to use. So the conversion ladder for metric is this, and we've seen this one before, right, several times. But this is our conversion steps here. Right, so metric conversions are always factors of 10. Right? So basically when we go down steps, right? When we go down steps, we times 10 for each step. So down 1 is times 10, down 2 is times 10, and then times another 10, which is the same as times 100, right? It's not times 20. That's people make that mistake pretty commonly. Going down 2 steps, you think, oh, times 10 twice. Well, that's the same as times 20, right? No, times 20 would be the same as times 10, then times 2, right? But if we're timesing by 10 twice, that's the same as timesing by 100. Right? So down 3 is times 10 times 10 times 10, which is times 1,000, etc. Right? So when we go we divide by 10 for each step, right? So let's say if we went up 3, it would be divide 10, divide 10, divide 10, which is the same as divide by 1,000. Up 4 would be divide 10. You see where I'm going with this? And so on. Right? So, this allows us to convert, and with a chart like this, which you will be given, um, this will enable you to convert, the common ones and also the uncommon ones, right? Like we don't often see the DAM or the HM or the DM, right? The hectometers, decimeters, and the decameters. That was out of order, but anyway. And there's plenty more. There's plenty more than these, right? Micrometers, yoctometers, nanometers, gigameters, megameters. Actually, gigameter is bigger than a megameter. That sounds pretty amazing, doesn't it? Megameter? Yeah, 1 megameter. It's a good terameter. Oh, picometer. Boy, now we're getting I don't know how big a picometer is in terms of like that one's got to be measured in like terms of atomic units probably, right? Fun fact: the atomic unit is the exact distance between the Earth and the Sun. 93 million miles. I could have won a million. I could have been a millionaire for knowing that one. That was the $1 million question on the first time on Who Wants to Be a Millionaire that someone won the million. I remember seeing that live. That's how old I am, you know? I was like 11 or 10. I can't remember exactly, but I did I do remember seeing it live. Not only how old I am, but how much of a nerd I am. That at like 11 years old, I was watching Regis Philbin on Who Wants to Be a Millionaire, right? Like, you know. But anyway, this is how you end up being a high school teacher. Oof. Big oof. Big oof for me. Um, okay, so say we were converting from, say we had, I don't know, 97 cm to DAM, right? So if we're going from 97 cm to DAM, well, we're going up 1, 2, 3 is up 3 steps. Therefore, we're going to do 97, and then we're going to divide, because we're going up, and we're dividing 3 times by 10. Divide 10, divide 10, divide 10, which is the same as 97 divide by. And I use this symbol to mean divide by most of the time. So it's going to be 97 divided by 1,000, right, which is going to be 0.097 DAM, like so, right? And say we wanted to go, I don't know, 1.38 dm to millimeters, right? This one is now down 2 steps, right? Because we can go over here, and we can see it, dm starts here, we go down 1, down 2, and then we're here. That's down 2 steps, therefore it's going to be 1.38 times 10 times 10, which is the same as 1.38 times 100, which is going to be 138 millimeters, right? That's just telling us basically how we go about doing these ones. Now, for the unit that you were just on, right, you actually didn't really need to know this one here, because you're given these ones over here. Wait, nope, that's the wrong sheet yet again. We've got several of these ones. Hold on, hold the phone. Well, you'd think I wasn't here like working all morning and preparing for this, but I mean, actually, most of the work I've been doing in any given morning is not preparing for the stream. But you know, these things happen. So formula sheet unit 3, is this the one I'm looking for? Yes. Okay, good. So don't mind that. That is for that's for another student that I'm going to get to momentarily. So Renetta, this is the one that you had for the current unit, and that one goes ahead and tells you that a meter squared is 10,000 centimeters squared. Kilometer squared is, holy moly, that's a million. That's a million meters squared. But how could we find that out on our own, right? How indeed? Well, let me just go back over to our metric steps. We have all the information that we need in order to find it just over here, right? Say we had to convert area, right? Say we had, I don't know, 3 meters squared to millimeters squared. How are we going to do that? Well, we know that, say we had a space, right? So just to show you kind of like what we did in the previous one, say we had a space here like this, that was 1 meter that way and 1 meter that way, right? That's going to equal 1 meter squared. But then, right, how many millimeters is each of those dimensions going to be? Yeah, I'll put down, I'll do the full writing there so that when you look at this in retrospect, you can see the area is 1 times 1, or 1 meter squared. So over here now, well, if we look over on our side, over here, we can see there's going to be 1 step, 2 steps, 3 steps down. So it's going to be 1,000. So it's actually 1,000 millimeters here, another 1,000 millimeters here, So the area is going to be 1,000 times 1,000, or the area is going to equal 1,000,000 millimeters squared, right? So similar to what we did for the previous, for the example that I did on the previous page, where I showed, why 1 square foot is 144 square inches. Well, that's the same deal over here. Come on now, camera. I'm not sure why it just got so dark all of a sudden. The lighting level did not change in the room. So we know that 1 meter squared is 1,000,000 millimeters squared. So this one's not going to be super hard now, is it? Because we've just found our conversion factor, right? So we can use this with unit canceling method just the same as our other conversion factors, right? We had to find it from our steps over here, but we can use it like any old conversion factor that we've seen thus far, because we'll have 3 meters squared. Now remember what we were just looking at, right? If the meters squared are the one that we're converting out of, that's the one that needs to be on the bottom. So we need to have our 1 meter squared here and our 1,000,000 millimeters squared on top. And I mean, this is now not a super difficult mathematical equation now, is it? It's going to be 3,000,000. Right? So it's just going to be a little aside over here. But say that we had to convert area and we weren't even given the conversion factor for the area units, we were just given the metric steps, we can still find it, and we find it thusly, right? So now I'm just going to go and I'm going to finish those last few, right? And I'm going to do it with unit canceling method, but I did want to just explain sort of how the metric steps work as well as doing these ones. So I'm just going to go yeah, so the first two are going to be like what I said, and the last one's going to be a little bit different. So this is unit canceling method examples again, right? And this is Math 1102A Review 3. This is going to be question 8B I'm going to do here. So we've got 1 meter squared equals some number of centimeters squared. Now, like I said, we know from our conversion, from our sheet, rather, I'll get it right one of these days. We know from our conversion ladder over here that we can see that there's going to be 100, because there's two factors of 10, right? 100 centimeters per meter. So it's going to be 100 times 100, right? Which is going to give us 10,000. But if we look at the formula sheet that you were given in this unit, we've even got it right there, right? You can see it right there. 1 meter squared is equal to 10,000 centimeters squared. So we were told that one straight up. Didn't even need to go find it. You might not always be given those. You might have to find them sometimes. But for this unit, they're taking it easy on you, and they're letting you have that one to go like that. So now we're going to keep doing a unit canceling method like we've been looking at today. We're going to put down 1.2 meters squared, and now we're going to multiply by our conversion factor. And again, meters are going to need to be on bottom because that's the ones we're trying to get rid of. That's the ones we're sort of looking to cancel. Right? So it's going to be 1.2 times 10,000, which is just going to be taking a 1.2 and then moving the decimal 4 places to the right. 1, 2, 3, 4. Fill in our zeros, and we get, obviously, 12,000 centimeters squared. Right? There we go. Let's look at question D here. So we've got kilometers squared to meters squared. Now again, we could find this one from our metric steps, but over here we're told straight up that 1 square kilometer is 1,000,000 square meters. So then once we were given that one, we can go ahead and use our unit canceling method, just like we did for all the rest of these questions that we've looked at today. That's going to be 3.45 kilometers squared times a million meters squared per kilometer squared. That's going to give us 3.45 million, quite clearly. I've run out of space. So it's going to be 345,000 meters squared. Okay? And then just to wrap this one all up, I'll do question F because why leave the last one there? Even though this one is not metric, this is back to being imperial again. But now we're back to yards squared to feet squared. So remember that there's 1 yard squared per 9 feet squared. And that one is on the conversion sheet as well, right? So we have our 11.5 yard squared, right? Multiplied by. Now we need to have the yards on bottom because we're trying to cancel the yards. So 1 yard squared, and then 9 feet squared on top. So it's just going to end up being 11.5 times 9, which is going to be 99 plus 4.5, which is going to be 103.5. There we go. And there, at long last, Renetta. That is should be a relatively exhaustive look at how we go about doing those unit conversions. I hope that has explained why we use this unit canceling method and why it works, right? But I'm going to send you those notes. They're now shortly after I wrap up for the day. So hopefully that will help explain, why this topic works like it does. Now, as a brief change of pace, I'm going to switch over. Let me go back to my intro screen for a second. Stream starts soon. No, it's already going. We can take one more another look at the cabin lot here with my nice fire pit. So we've done the first 3 bullets: unit conversions, metric ladder, definitions, conversion factors, and unit canceling method sorted. So now inductive versus deductive reasoning. I am going to do a brief bit on that. It's not going to be super long. I wanted to do, let's see, I want to do at least 2 questions on page 35. So let me go find that here. Here we go. Back on over. So this is Betty Ann. This is stuff for your course again now. This is page 35 in your textbook. And I'm going to do 2 of the examples down here in the corner. I've done number 9 before, but I'll tell you what, I'll do 9, 10, and 11. I didn't mean to do 9 first, but 9's fairly fast, and that's a good one because there's pretty likely to be ones like that on the test that you do, right? So this is going to be Math 2101A review. Right, and this is going to be page 35. Don't mind that it says mid-chapter review, right? Of course, we're sort of cobbling these courses together from different parts of books in different places, just like teachers always do, right? So question 9, prove that the sum of 4 consecutive natural numbers is always even. Well, just a reminder, prove means use deductive. Right? Remember, deductive reasoning is operating with algebra symbols, right? We're going to show that this is always true. Whereas inductive reasoning would be to take just a few examples and work through it, and so that it will show that it works out a lot of the time, but that's not the way we're going to do it here now. 4 consecutive natural numbers. All right, so 4 consecutive natural numbers can be x, right, plus x plus 1 plus x plus 2 plus x plus 3, right? That's 4 numbers, and those are all sequential. Because whatever x is, this is 1 more than that, this is 2 more than that, and this is 3 more than that. So that's 4 numbers in order. I'm going to go ahead and add those guys up. We're going to have 4 x's once we do that. We're going to have a 1 here, a 2 here, and a 3 here, and that's going to be a plus 6. And now clearly we can factor a 2 out of both those, right? We can call that 2 outside of 2x plus 3, right? There we go. So since our final answer can evenly be divided by 2, it must be even, right? Easy peasy. But that's a real good sort of meat and potatoes kind of question for this sort of unit, right? It's the basics. Not necessarily basic as in like easy, but it's basic as in, this is the real sort of stuff that you're going to get asked, right? Not to point elbows a bit too hard or anything like that, right? Now, question 10, I do want to do that one as well. Consider the following statement. The square of the sum of two positive integers is greater than the sum of the squares of the same two integers. Whoa. All right. That was a lot of words. Oh, those were a lot of words. If you approach a question like this and all of a sudden you're sort of like gobsmacked by the amount of terminology that's thrown at you, just try writing it out bit by bit, right? The square of the sum of two positive integers. Yeesh. Okay. Um, so I'm going to do x plus y. So the square of the sum is greater than the sum of the squares of the same two integers, right? Test this statement inductively with 3 examples, then prove it deductively, okay? So what they're saying is that that is going to be greater than x squared plus y squared, right? So that's kind of what they're saying, is that the square of the sum is greater than the sum of the squares, right? Sounds a bit awkwardly phrased, but this is what it means. Now, is this true? Well, let's find out. All right, so then inductive kind of means a pattern, like we saw before, right? So we're just going to try it a few times and see. So I'm going to do, say, 2 plus 3 squared is equal to 5 squared, which is 25. Whereas 2 squared plus 3 squared is equal to 4 plus 9, which is equal to 13. Okay, well, I can clearly see that 25 is greater than 13. So that checks out. So let's try it again. 7 plus 4 squared is going to be 11 squared, which is going to be 121. 7 squared plus 4 squared is going to be 49 plus 16, which is going to be 65. Okay, so clearly 121 is bigger than 65. So we're getting there so far. Test the statement inductively with 3 examples. All right, so we want a third one. Okay, so let's do 10 plus 17 squared is going to be 27 squared, and I don't know that one off the top of my head, so I'm going to go ahead and do 27 squared over here, 729. So then 10 squared plus 17 squared is going to be 100 plus, is that 169? 289. Nope, never mind. 289. No, that's 13 squared I was thinking of. So that's going to be 389. Clearly, 729 is bigger than 389. Okay, that wasn't hard. But now, how are we going to go about proving this one deductively? Well, this, now I could have, if I wanted to actually show that these had to be positive integers, I could technically have put the absolute value signs around each of these guys. Absolute value of x plus absolute value of y squared. Or I could have had these square from the start, right? Because if you square a number, it always becomes a positive. So there's several different ways that I could have forced these to be positive all the time to actually be ultra pedantic, right? Because it said sum of two positive integers. So if I squared this from the start and squared this from the start, and then had this one be to the power of 4 to the power of 4, that would have guaranteed that I was starting with positive integers. But the answer key in your book doesn't do that, and I don't think there's any real. We don't need to get quite that level of pedantry. Although I do approve of technical correctness. I gotta say, right? But yeah, it's not we're not following through with that sort of in the rest of the course. So I'm okay with just doing it out thusly. But now, how are we going to prove deductively? Well, what's x plus y squared? What is that? Well, that equals x plus y times x plus y, right? If we were to FOIL these guys out, we're going to get x squared plus um, xy plus another xy plus y squared, which is going to be x squared plus 2xy plus y squared, right? And clearly then, um, if x and y are positive, x squared plus 2xy plus y squared must be greater than x squared plus y squared, right? That just follows. And if we go through and we simplify this as much as we can, we could call this 2xy is greater than x squared plus y squared minus x squared and minus y squared, because we just moved that x squared and y squared over here. 2xy is greater than 0, right? So we know all the rest of this. All that part there wasn't super duper important to write down, but this is what we're looking at, right? Because this term here has this 2xy in the center, whereas the other one does not. That's what makes this one always greater than the other one over there, right? And again, like if we wanted to be totally pedantic and have it not matter if x and y are positive from the start, we could have called this x squared plus y squared is greater than x to the 4 plus y to the 4. But, we're not, again, I'm not going to bog you down with that right now. And I would also like to do question 11 on this page here. So prove that the difference between the square of any odd integer and the integer itself is always an even integer. Okay, so how can we represent that in sort of algebra language that we can use to create deductive reasoning? Well, the square of any odd integer. So how do we represent an odd integer? Now remember, we to represent an odd integer, we kind of had to start with an even integer, right? An even integer we know is 2x is how we write it, because no matter what x is, right, 2 times it is going to be even. And since this is always even, to make something always odd, we're going to go ahead and add a 1 to it, right? Because if we take an even number and add 1, that's always an odd number. So the difference between the square of any odd integer, so this is the square of any odd integer, and then subtract the integer itself, where the integer itself is 2x plus 1, right? And that is always an even integer. Okay, so let's figure it out. Let's figure out if this will result in an even integer every time. So I'm going to go ahead and FOIL this guy. I'm going to write out the steps. I'm going to leave this bracket here for now. It is important to leave the bracket. I do find leaving the brackets in helps you to manage the subtraction, because if I was tempted here to leave this bracket out, I might accidentally call this minus 2x plus 1 and leave this as a plus. But as soon as this bracket goes away, this becomes a minus 2x and this becomes a minus 1, right? So it is important to know we're subtracting this full bracket, which means both the terms inside the bracket have to become negative. It's a super common source of Mark's lost for people. So there's going to be a 4x squared plus a 2x plus another 2x plus a 1, and then it's going to be minus 2x and minus 1, just like I was saying, right? So I go through and combine this. I'm going to have 4x squared plus 4x minus 1, then minus our 2x and minus 1. I'm doing this just a little bit at a time. We'll have our 4x squared. This is going to be a plus 2x, and this is a minus 2, which we can call 2 outside of 2x squared plus x minus 1. And again, just like above, since our final answer since our final answer can be evenly divided by 2, it must be even. Okay? So, Betty Ann, that was a brief review of inductive versus deductive reasoning and proofs that I wanted to go down through. Um, this course is is the last time you're going to see this topic in very much detail, like um, the inductive versus deductive stuff. But you are going to have to know, of course, the algebra skills that this is building, and all the ability to rearrange stuff like I've been showing is super important, of course. But yeah, that brings me to the end for another day. Right, it's another stream down. Thanks for joining me here on this wonderful midweek Wednesday. Hope that social distancing is still finding you well, that you're getting courses done and completed, uh, staying busy, staying productive. I'm super glad to see the buy-in that we're still receiving here in the program. And yeah, happy to be here, you know, helping you guys get your math done, get your science done, and yeah, get your credits at this time when a lot of people are spinning their wheels. Not I mean, not to slight anybody else, right? It is a tough time for a lot of people in a lot of positions and a lot of professions, but we happen to be very lucky that we are able to keep going. I'm able to keep working. You guys are able to keep working, so we're really fortunate. And yeah, it's great to see people taking the opportunity to improve their education, right? Yeah, hope you stay safe, and I'll see you again tomorrow.